Good afternoon, good morning, good night. Who knows where we are? Today we are taking a look at a little bit of recursion, looking at interest and depreciation. So, taking into account that this stuff all relates to real life things, we're building up to understanding how this affects money, the cost of things, the value of things, whether that be increasing or decreasing over time. Okay, so let's dive straight into it. Here we've got an initial deposit of $8,000. We're going to do some simple stuff first. My pen on the right angle. It's always good for you to stuff before you start your videos. We'll deal with it. So on the initial deposit of $8,000, find the interest earned per period on 5% per annum, 0.8% per month, and 0.05% per week. Okay. So we'll remember that we're at the moment doing this in terms of I equals, where am I? PR over 100. Okay, so that means A, where P is the initial amount we're investing, so $8,000, times R, the rate, which is 5. Because we're dividing it by 100, we're not going to change that 5 to its decimal version like you might in some things when we're using percentages. Okay, so we've done that. Jump over to, remember that my calculator's on a different screen, and go 8,000 times 5. I'm just going to hit equals and then divide by 100. And we get 40. So what does it mean? It means that for every year, this account is earning $40. Really not happy with how my, that's better. Okay. All right, part B, same thing. Now, even though we've got per month here, we've got to remember we're asked to look at what's earned per period. Okay, so we're not actually changing, we're not dividing anything by 12, we're not timesing anything by 12. The period is a month, and that's 1. So all that means is we're being told how often the interest is charged, and we're going to find out what amount we earn each period. Okay, so for this one, we're going to go 8,000, same starting amount, times 0.8, and divide that by 100. And we get a calculator. I didn't want to hit this time, clear that. Times 8 divided by 100 equals $64. Okay. Okay, I just paused the recording there because I noticed something that's a bit unusual. So back on the calculator right now. So you may have noticed I didn't actually hit 8,000. I hit 800. And what I noticed was that I got $64 for 0.8% interest on $8,000. And over here, I got $40 for interest of 5%. And I was wondering why. What have I done? That means that's something incorrect. So what I did on the calculator, you can see on the screen right now, hopefully, is that I put in 800 and not 8,000. So with all that being said and done, we would actually make $400 a year on that investment, not 4,000. Okay. And last one, always important to check how many zeros you've got. Makes a big difference. Our interest earned in this one is equal to $8,000 started with again, times 0.05, all divided by 100. And if we go back over to the calculator, and let's go 8,000 times 0.05 equals 100 divided by 4. It's equal to $4 there. Now you might say $4, well, that's pretty rubbish, but if you think about it, that's per week. So multiply that's 4 by 52, and you end up with $200 something. Not quite as good as the first one, but just need to take into account that when we get down to the nitty gritty of this in a few weeks' time, probably, that this, how often we're applying the interest, so per annum, per month, per week, is super important to how much money we've got at the end of the day. Alrighty, next one, we want to write the equation for the following scenarios. So these scenarios, we have to remember simple interest or unit cost depreciation are both going to be flat lines. So we're going to be taking or adding the same amount each time. And this first one says a new motorbike. So our basic equation is this. So any term, Tn, is equal to A plus ND. Hopefully we know that we can change that plus for a negative if it's going down. So for A, to start with, we've got a new motorbike is worth $35,000 and depreciates at a rate of 0.03 cents per kilometre. So Tn, we don't need to change anything there. A is the initial value of the motorbike. So $35,000. Nice shiny one at that price. And it's depreciating, so we've got to put a negative in there, subtraction. Okay, depreciates at ND, so the difference is 0.03 times N. Okay, how many kilometres? Now you can see I've changed the N and the D around there. It doesn't matter. If you wanted to put it like this, it's a bit nicer when you've got the coefficient in front of your variable. Okay, if you really wanted to put it like this, just because your brain gets used to it, it's not going to make a difference to your outcomes of your equation, but this is the preferred version. Okay, so that's the equation right there. Going up a different color just because it's going to get pretty bland, all this black everywhere. B. Using simple interest, a loan is taken for $7,000 and has a rate of 0.5% per month. Okay, first thing we need to do for this, all right, we know A for this question. We don't know D. We know the interest, but we don't know D. So we've got to go back and look at what we did in our green questions over there. And go, right, our interest is equal to D. The difference is P, which is $7,000 times 0.5 divided by 100. Go work that out. Times 5 and divide it all by 100. We get $35. That equals 35, okay, which is equal to A. Sorry, not A, that is equal to D. Alrighty, now we can write our equation. So Tn, same start. A is $7,000, starting balance of our loan, and then interest, we're getting charged interest. It's adding on to the balance, even though it's a negative thing, because this is that money we owe, adding on to the balance. So we add it, and it's going to be 35, and we've replaced n with the months at some point. Now, next one, give the value of n in these scenarios. So the depreciation is calculated fortnightly over 7 years. Okay, so if we had an equation and we were calculating the fortnightly depreciation over 7 years, n is going to equal 26, because there's 26 fortnights in a year, times 7. And that over here. And n value for that would be 182. So when you put it in the calculator, we have an n value of 182. Last one, part B, an investment gains interest monthly for 17 years. So, for 17 years, so we're asking ourselves how many months are there in a year? We say there's 12, and that's multiplied by 17. Come over here again. I say come over here because I've got my calculator on a different screen. And that is 204. All right, so that's placing those values into n. Okay, last question, the red one down here, shiny red one. Okay, Miles bought a second-hand car for $7,000. If it loses 0.25 cents in value for every kilometre driven, what will be its value after being driven 12,000 kilometres? Okay, first thing, let's set up our equation. So Tn, same as always, equals A, it's going to be a minus ND, because it's depreciation. And we know that he bought a second-hand car for $7,000. Saved up his hard-earned cash. And it depreciates at 0.25 times n. Okay, now I'm going to keep that there. I could have put in the n straight away, but just to show how we set up the equation. Okay, so that's Pn. Now, that means that T, 12,000, because we're changing the n to 12,000, is equal to 7,000 minus 0.25 times 12,000. Okay, now let's make sure we've got all of our zeros in our calculator properly. And I don't even have all the zeros on the screen properly. One there. 7,000 take 0.25 times 12,000. And T 12,000, because it's not n anymore, n is any value, T 12,000 is equal to 4,000. So we would say the car is worth $12,000. $12,000, what am I saying? The car is worth $4,000. Right. And that's how we apply interest and depreciation to real life scenarios, and really finding the nth term of an arithmetic recursive sequence. Okay, hope that helps, guys. Smash like buttons, hit subscribe. Love everything, and have a great day. See you again.